Assalamualaikum and hi to all the panels. My name is Auni Diana binti Muhammad Nizam and I'm from University Technology Mara, Perlis branch. Today, I'm excited to present our research titled The Effect of pH on Adsorption of Copper Ion by Calcium Ion Layered Double Hydroxide, CaFeLDH. Copper ions are widely used in industries such as electroplating, mining, and metal finishing. However, the discharge of copper into the environment through untreated industrial influence poses significant health and environmental risks. Elevated copper concentrations in water can cause serious health problems such as liver damage, gastrointestinal issues, and enzyme inhibition. Furthermore, copper ions disrupt aquatic ecosystem by accumulating in organisms, causing long-term damage to biodiversity. Existing methods for copper removal, such as chemical precipitation and ion exchange, are often expensive and generate secondary waste. Alternatively, layer double hydroxide LDH, particularly calcium ion LDH, have shown potential as low-cost, high-efficiency absorbent for removing heavy metals like copper. This study investigates the effect of pH on the adsorption of copper ion using CaFeLDH with the aim to optimize conditions for enhanced copper removal and improve water quality. For the synthesis of CaFeLDH, we employ a co-precipitation method in which 0.1 molar calcium chloride and 0.05 molar iron chloride were combined in a 2:1 molar ratio with 0.03 molar sodium chloride serving as a stabilizing agent. The pH of the solution was adjusted to 5.5, 7.5 and 12.5 using 2 molar sodium hydroxide to simulate acidic, neutral and alkaline conditions. These pH values were selected to explore how pH affects copper removal efficiency. After synthesis, the suspension was aged at 60 degrees Celsius for 24 hours to allow the formation of the LDH structure. The suspension was then centrifuged at 4000 rpm for 15 minutes and the solid phase was dried at 70 degrees Celsius for 48 hours to prepare the adsorbent. For the copper removal experiments, we treated 1 gram per liter CaFeLDH with a 10 ppm CO2 plus solution and measure the removal efficiency at contact time of 0, 30 and 60 minutes with a stirring rate of 240 rpm. To assess the copper removal performance, we use inductively coupled plasma optical emission spectroscopy (ICP-OES) and measure the turbidity of the supernatant. Now, moving to the Fourier transform infrared spectroscopy (FTIR) results. As shown in Figure 1, we use FTIR analysis to identify the functional groups involved in copper absorption on CaFeLDH. The FTIR spectra before and after copper absorption show several significant peaks. The broad OH stretching peak at 3,300 cm inverse indicates the presence of hydroxy group which are essential for the interaction with copper ions. After copper absorption, the intensity of this peak increased, suggesting that the hydroxy group are actively involved in the absorption process. The MO bonding peak at 712 cm inverse confirms the presence of metal-oxygen bonds typically of LDH structure. Another key peak is at 864 cm inverse, which represents the CaOH bending vibration and indicates the involvement of calcium hydroxide in copper retention. Additionally, the C-double-bond-O stretching peak at 1476 cm inverse became more intense and broadened after copper absorption. This indicates the formation of carbonate ion likely due to the reaction of carbon dioxide from the surrounding environment during synthesis, which plays a role in enhancing copper retention. This finding confirmed that copper ions interact with the hydroxy groups and other functional sites on the CaFeLDH surface, enhancing its ability to absorb copper ions, especially at higher pH. Next, let's look at the inductively coupled plasma optical emission spectroscopy ICP-OES results, which are shown in Figure 2. The analysis revealed a significant decrease in copper concentration after treatment with CAFE-LDH at all pH levels. At pH 12.5, the initial copper concentration of 8,820 mg per liter dropped to 43.96 mg per liter, resulting in 84.60% removal efficiency. At pH 7.5, the concentration decreased from 9,268 mg per liter to 376.95 mg per liter, giving an 83.58% removal efficiency. And at pH 5.5, the concentration reduced from 8,780 mg per liter to 384.88 mg per liter, leading to an 83.34% removal efficiency. This result highlights the importance of pH in copper removal. The higher pH values enhance the negative charge of the CAFE-LDH surface, which helps in better attracting and absorbing the positively charged Cu2 plus ion. This finding is consistent with previous studies showing that alkaline conditions improve the absorption efficiency of copper. Let's now look at the turbidity result shown in Figure 3, which illustrate the improvement in water clarity after the copper removal process. At pH 5.5, the turbidity was 2.25 NTU, but after the absorption process at pH 12.5, it decreased to 0.35 NTU, demonstrating a significant improvement in water clarity. This reduction in turbidity is an important indicator of better water quality after copper removal. This decrease in turbidity aligns with the observation that higher pH conditions improve flocculation and settling of the CAFE-LDH particles. In addition, contact time played a role in enhancing copper removal. At 0 minutes, the removal was 80.85%, but at 60 minutes, it increased to 90.96%, demonstrating that longer contact time improve both copper removal and water clarity. The mechanism behind these improvements are related to the Fe3 plus ion in CAFE-LDH, which enhance anion exchange at lower pH and facilitate surface complexation at higher pH. This shift in mechanism is key to understand how CAFE-LDH works more efficiently in alkaline condition where absorption is enhanced. In conclusion, this study demonstrates that CAFE-LDH is an efficient, low-cost, and environmentally friendly absorbent for copper ion removal from aqueous solution. The highest removal efficiency of 90.96% was achieved at pH 12.5, and the treated water met WHO turbidity guidelines, making it suitable for consumption. Our results show that pH plays a crucial role in optimizing copper removal, with alkaline condition providing the best result. CAFE-LDH not only remove copper ion effectively but also improve water quality by reducing turbidity, making it a promising material for water treatment. Looking ahead, we plan to expand this research by testing the effectiveness of CAFE-LDH for the removal of other heavy metals. We also aim to evaluate its performance in real wastewater sample to assess its applicability in industrial-scale water treatment. Additionally, we intend to explore scaling up the process and investigate the reusability of CAFE-LDH for long-term use in water treatment systems. I would like to thank Grant Semarak Pendidikan UiTM Cawangan Perlis for funding this research under Grant 600 UiTM PS PJI UPP GSP 02 2024. Here are the references used in this research. Thank you for your attention.